from the kind of star it is to its impact on our world and more. Join me as we explore the sun, facts, and history. Number 8. Our Sun. Without a doubt, if you were to list the most important things in the solar system we live in, the Earth may be number 1, but the Sun is number 2. And for all the reasons that you might expect and know. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest particles of debris in its orbit. Electric currents in the Sun generate a magnetic field that is carried out throughout the solar system by the solar wind, a stream of electrically charged gas blowing outwards from the Sun in all directions. The connection and interactions between the Sun and Earth drive the seasons, ocean currents, weather, climate, radiation belts, and aurora. In short and in long, the Sun is vital to just about everything we do on this planet. And we rely on the Sun to do many things, even though we're honestly not controlling anything that it does. Which is a bit of an odd thing for humanity, as humans like to control everything that has to do with us. The Sun is something we see almost every day. Obviously, unless cloud cover is blocking it or an eclipse is happening. And even when we don't see it, we feel its presence. It's more than just a ball of light in the sky. It's an energy source, a lifeline in many respects. And as noted above, it helps shape our planet in various ways that would be detrimental if it wasn't doing it. So if someone was to honestly ask you just how important the Sun is, you should tell them all the ways we need the Sun, our star, to shine on. Number 7. Distance from Earth and its size. With a radius of 432,168.6 miles, or 695,508 kilometers, our Sun is not an especially large star. Many are several times bigger, but it is still far more massive than our home planet. 332,946 Earths match the mass of the Sun. The Sun's volume would need 1.3 million Earths to fill it, which at first might seem like a bad thing. After all, would we want to have a giant ball of fire and radiation just lurking out there that can swallow us whole if it felt like it? Honestly, yes we would, and for a very simple reason. Its distance from the Earth. The Sun is 93 million miles, or 150 million kilometers from Earth, which is a very long ways away. And in fact, it's such a distance that they came up with a term for it via astronomical unit. So when you hear that a planet or star is, say, 103 AUs away, that means that it's 103 times the distance between the Earth and the Sun. Going back to the distance itself, you might think that this is a very long way away from the entity that gives us light and essentially life. But actually, it's better that we're not closer to the Sun for a whole host of reasons. Sunlight and its energy dissipates the farther you get away from it, which is why there is such a thing as a habitable zone in regards to stars where life can exist, as well as water and other key things needed for life. The closer you are to a star, the more impact you're going to get from its heat and light. The farther you are from a star, the less likely you're going to get heat and light in the amounts you need. Lest you think we're exaggerating this, we have the perfect examples for this. It's called Mercury, Venus, and Mars. Mercury is the closest planet to the Sun, and it's scorching hot as a result. Its average temperature is 800 degrees Fahrenheit. Plus, because it's so close to the Sun, it's tidally locked, meaning that it has one side always facing the Sun, and the other side is always away from it. In regards to Venus, it's our twin, but also a case of the Sun's energy turning it into something else entirely. A buildup of heat and excess carbon dioxide turned it into a runaway greenhouse planet, which makes it so hot that it can melt lead. And it's also the hottest planet in the solar system because of the greenhouse effect, which was caused by the Sun's radiation. Heading to Mars, it's so far away from the Sun that it can't absorb the sunlight and energy like we do on Earth. So its average temperature is minus 81 degrees Fahrenheit. Not to mention it doesn't have a typical atmosphere in any sense, so various solar and cosmic rays bombard the planet. And it's also so far away from the Sun that even if Earth settled on the planet, using solar panels to get energy for colonies wouldn't be as viable as you think because the distance is so great. So as you can see, it's good that we are 93 million miles away from the Sun. It's the literal perfect spot to be in to get the positive effects of the sun without many of the negatives. And if you're curious, its nearest stellar neighbor is the Alpha Centauri triple star system. Proxima Centauri is 4.24 light-years away, and Alpha Centauri A and B, two stars orbiting each other, are 4.37 light-years away. A light-year is the distance light travels in 1 year, which is equal to 5,878,499,810,000 miles, or 9,460,528,400,000 kilometers. Before we continue to break down the sun, be sure to like or dislike the video. That way we can continue to improve our content for you, the viewer. Be sure to subscribe to the channel too, so that way you don't miss any of our weekly videos. Number 6. Orbit and rotation. The sun and everything that orbits it is located in the Milky Way galaxy, as you well know. More specifically, our sun is in a spiral arm called the Orion Spur that extends outward from the Sagittarius arm. From there, the sun orbits the center of the Milky Way galaxy, bringing the planets, asteroids, comets, and other objects along with it. Our solar system is moving with an average velocity of 450,000 miles per hour, 720,000 kilometers per hour. But even at this speed, it takes us about 230 million years to make one complete orbit around the Milky Way, which is quite astounding when you think about it. The sun rotates as it orbits the center of the Milky Way. Its spin has an axial tilt of 7.25 degrees with respect to the plane of the planet's orbits. Since the sun is not a solid body, different parts of the sun rotate at different rates. At the equator, the sun spins around once about every 25 days. But at its poles, the sun rotates once on its axis every 36 Earth days. Imagine if something like this happened on our planet, where the days were different based on what section you were on and how fast it was rotating. That would be a very hard schedule to keep up with. Thankfully, we don't have to worry about that as we are a solid planet. Number 5. The sun's formation. Let's talk about how our sun got formed, shall we? Long before our solar system was born, the universe was a big wasteland of nothing. Or at the very least, that's what we believe it was. Then, through one means or another, there was an event known as the Big Bang. This expansion of energy and matter spread throughout the universe, both known and unknown, and created a great many things. And when it didn't specifically create something, it left the building blocks to all things to be made. In regards to our solar system, that would be what is known as the solar nebula, or to break it down for you, a massive cloud of gases and matter and particles and molecules. But how does it go from a massive cloud to a bright ball of warmth and energy we call the sun? The answer to that is time, pressure, and a little bit of luck. Most scientists who believe in the solar nebula theory understand the concept of the cloud being there and then somehow starting to make the planets and the sun. But what many aren't sure about is the actual event that led it to folding in upon itself. What we do know, or at least can theorize, is that when this started to happen, when the solar nebula started to destabilize, it compressed upon itself. And when you have a massive thing of gas folding in on itself, things tend to get massive. And as the cloud began to compress, it also started spinning, until eventually there was a giant pancake disk spinning around in our solar system. Not exactly a sun, but a big step in getting there. In fact, most label this as a protostar, and when that happened, the sun was born, right? Not exactly, because while it was a protostar, it was still a pancake. It's estimated that over the next 50 million years that the sun slowly gathered more mass and more energy from the cloud, likely due to its spinning nature and the gravity it was exuding. Eventually, once it got enough mass and energy, the process of nuclear fusion began in the sun, and that led it to being the big ball of light and fire that we call the sun. So a major piece of our solar system had been made. All told, our sun is believed to be as old, or pretty close to being as old as our whole solar system, which would mean that right now our sun is about 4.5 billion years old. Number 4. How its formation affected the solar system. But that's not the end of the story in regards to formation of our system, because as noted earlier, the sun has a massive gravity to it, and that gravity started to reach out across the barren parts of the solar system and started to make things happen. Though as some noted, it wasn't exactly a masterpiece of creation. Many speculate that when the sun got fully formed and its gravity loomed large, things just happened. This is one of the reasons why there are so many objects in our solar system, and why there are so many different kinds of planets. Some of the planets are gas giants because that's all they had to work with, or they had solid dense cores and the gases just run to that. And when they were big enough, and such regular matter like rocks and stuff couldn't stick to it. In contrast, planets like Earth, Mars, and others were able to go and be solid because of the matter that was around them. The gases of the nebula were still a part of them, but they were absorbed either into the ground or into the very atmosphere itself. As things formed, things slowly changed in how the solar system worked, again because of the star. Once objects were a true certain mass, they went into orbit around the sun. Other objects were launched into space or pulled closer to the sun and collided with other objects. Some think that this is what happened to the Earth that caused the moon to be formed in a roundabout way. All told, the way our solar system looks right now is because of the sun in large part. Thus, we owe it more than we could ever realize. Number 3. Construction. It's very easy to say that the sun is a giant ball of light and heat, but in truth it's much more complicated than that. In terms of the number of atoms, it is made of 91.0% hydrogen and 8.9% helium. By mass, the sun is about 70.6% hydrogen and 27.4% helium. The sun has 6 regions: the core, the radiative zone, and the convective zone in the interior, the visible surface called the protosphere, the chromosphere, and the outermost region, the corona. The sun's enormous mass is held together by gravitational traction, producing immense pressure and temperature at its core. At the core, the temperature is about 27 million degrees Fahrenheit, or 15 million degrees Celsius, which is sufficient to sustain thermonuclear fusion. This is a process at which atoms combine to form larger atoms, and in the process release staggering amounts of energy. Specifically in the sun's core, hydrogen atoms fuse to make helium. The energy produced in the core powers the sun and produces all the heat and light the sun emits. Number 2. Atmosphere. Above the protosphere lie the tenuous chromosphere and the corona, crown, which make up the thin solar atmosphere. This is where we see features such as sunspots and solar flares. Visible light from these top regions is usually too weak to be seen against the brighter protosphere, but during total solar eclipses, when the moon covers the protosphere, the chromosphere looks like a red rim around the sun, while the corona forms a beautiful white crown with plasma streamers narrowing outward, forming shapes that look like flower petals. Strangely, the temperature in the sun's atmosphere increases with altitude, reaching as high as 3.5 million degrees Fahrenheit or 2 million degrees Celsius. The source of coronal heating has been a scientific mystery for more than 50 years. Number 1. The end of our star. Defining the end of a star's life is a bit more complicated than you might expect, mainly because stars don't die in the traditional sense most times. They go into different phases of life and sometimes die in order to create new stars. In the case of our sun, which is a yellow dwarf, it'll die in its current state in about 5 to 7.5 billion years, depending on who you ask. When that happens, it'll become a red giant, which is significant because these are much bigger than yellow dwarfs. In fact, when that happens, the Earth will honestly die, because the sun will swallow it up in its new state more than likely. Some even speculate that the red giant could consume everything up to Jupiter. Again, this is many billions of years away, but it will happen. And much like the sun made our solar system, the sun will also help to destroy it. Thanks for watching, everyone. What did you think of this look at the sun and its facts and history? Are you surprised by how much the sun has helped shape not only our world, but our solar system? Which of these facts did you find the most interesting? Let us know in the comments below. Be sure to subscribe, and I'll see you next time on the channel.